Hey guys, Will here. So unfortunately we had a bit of an accident here in the Boosted Media studio. My DD2 was sitting up on a shelf about 1.5 meters off the ground, and unfortunately the shelf collapsed under the weight of the DD2 and it fell directly on its nose like that onto my desk, put a big dent in my desk and has completely seized up the shaft. You can see there, I can't rotate that at all. So I'm hoping that today we'll be able to maybe fix this, but I don't have high expectations. We're going to pull it apart. We're going to have a bit of a look internally, but from what I've seen on Fanatec's YouTube channel, some of their marketing materials, there's quite a bit of electronics that actually sit on the back of the motor assembly here. We've got the optical pass-through for the data connection to the wheel, as well as a key wireless charging inductive coupling system as well. And that all kind of sits behind the motor shaft. And I'm expecting what's happened is when that motor shaft is pushed through the housing, it's probably just completely destroyed all of that stuff internally. So we're going to pull it apart today. We're going to try and at least get some interesting content out of this crappy situation. We'll pull it apart, we'll have a look and see exactly what we find. So we'll start off by, I guess, seeing if we can actually pull that back out. I mean, it seems to have just kind of pushed in. So I've grabbed an old tire lever from my push biking days here, and I don't know whether this is going to work or not. I'm going to try and do it in an inconspicuous area. I'm putting marks on the plastic there. I might actually get a, I've got a microfiber cloth here as well. Let's see if we can wedge this out. There we go. Okay, that popped. I felt a little pop there. So let's have a look. Okay, well that actually feels normal. So I can feel the normal graininess there. I'm not feeling any crunching or anything. And the shaft doesn't seem to be bent miraculously. I was kind of expecting that once I got this spinning, if I was able to get this spinning, I might sort of see it buckling up and down, but it seems to be rotating pretty cleanly. So, I mean, maybe that's all that was wrong. Maybe it will actually be salvageable. So I guess we'll power it up. I'm a little bit nervous about switching it on. I don't know what's going to happen, but I've got the power supply here. So, and I'm actually feeling really anxious about this. I really hope it works. I don't expect it will work. Probably put on some gloves or something as well. Oh, legend, thank you. Just in case it does go absolutely berserk on me. I don't want to rip up my hands or anything. Let's put these on for protection. Okay, I feel a little bit safer now. I do have the power supply in my lap too, so I can quickly pull the power cable if I need to. Let's have a look. All right. Yeah. Well, it powered up. It didn't damage my table anymore, so that's good. But yeah, I think it's safe to say that she's dead. It did, yeah. I'm guessing. I mean, I saw the display come on and everything. I'm guessing probably what's happened is, as I suspected, the encoder on the back of the motor shaft is probably completely destroyed, so it had no idea where it was in space, and it was probably trying to, calibrate itself off no data or corrupt data. I'm guessing that's probably what's happened. So we'll start the process of pulling this apart. Now I have popped the covers off these before when I did my comparison between the DD1 and the DD2. So I know that there's not a whole lot that you can see on the back of the motor housing in terms of the internal workings. So I'm guessing we're probably gonna have to tear this down pretty fast to at least get a look at the damage. So let's get started on the process here. We've got these 4 bolts on the back here, which we need to undo. This whole assembly kind of slides away from the back of the motor. And there's 4 shafts that actually run through all the way through the front. So I'll get started on that first. I've got my Allen keys here. Don't need too many tools to do this, hopefully. So because these have been undone before, they're a little looser than they would otherwise be. Now, some of these will probably come out with the studs. I think this one's going to, yeah. So that stud actually goes all the way through to a thread in the front. But the last time I pulled this apart, it didn't, they didn't all come out that way. One of them was the stud stayed in. It's a little bit of a pain to put these back together again if you do ever pull yours apart for some reason. I would recommend not pulling it apart unless you have specific reason to. Yeah, there you go. So that one, the stud actually stayed inside, but that's okay. And I don't really want to sort of make this a disassembly guide, so to speak, because I don't really know what I'm doing here either. I'm just kind of sharing the experience as I go. That one came out with the stud. There we go. Okay, now this rear housing should sort of come off. We can pop off these magnetic covers as well. Okay, so that part comes off, but I think we're gonna need a little screwdriver to just kind of pry this. Grab my baby screwdrivers here. Let's try and pry this away. I'm trying to do it in an area where it's covered, just in case we are able to fix it. There we go. All right, so release this. There we are. Okay. I remember the first time I popped these covers off, I was really anxious because I wasn't sure exactly how it happened, or how it would work, but it's not too bad. Okay. Covers off. So I'm gonna disconnect the main motor power here, just to give us a little bit more wiggle room. So when I opened this up, the first thing I actually noticed was a little bit of a smell of, I wouldn't say burnt electronics, but it smells like silicon that's gotten very hot. So something is definitely not happy in here, and I'm guessing probably when we switched it on, whatever was damaged in the back here probably got even more damaged. We can't, as I said before, we can't actually see exactly what's going on behind here. I'm not sure whether this is part of the encoder or part of the wireless charging assembly or anything like that. So we're gonna have to take these connectors off. It does have this kind of plastic stuff on it as well. It seems to flake away pretty easily, so I'm hoping we should be able to sort of chip away at that with a screwdriver, and that will allow us to undo these plugs. But a couple of interesting things here that we can see in the back. We've got a cooling fan here which actually draws air through, and if we spin the whole thing around, you can see the little filter in the front here. Hopefully you guys can see that. So what's happening is air is actually being drawn through that filter and then being sucked around the entire housing, and you can see there's actually an open cavity all the way around here with heatsink fins, which we'll get a better look at once we pull this whole thing apart later on. So it's actively cooled with air that passes through over the heat sinks on the motor. So I've never actually really felt this get warm when I'm driving, so it seems to work quite well. We can see a couple of ferrite chokes here on our data lines going into the motor housing as well. The cables themselves aren't shielded, but I mean, I guess that's not really necessary, otherwise they'd do it. And then we can see two what's called braking resistors there as well. Those are 50 watt. And the function of those is basically to dissipate any excess voltage generated by the motor when it continues to spin after power has been removed from it. So a lot of people don't realize that a generator, or a dynamo as it's called, actually works like a motor in reverse. So instead of current being passed through the coils to make the motor spin, what's happening is the inertia of the motor, or the momentum of the motor spinning, actually generates an electrical current which passes back through into the electronics, and that can cause all sorts of different problems. One of those issues being that it can cause the motor to continue spinning when you don't want it to. So what happens is these braking resistors actually bleed off that excess voltage to cause the motor to stop more quickly, or basically behave exactly as it's commanded to, rather than sort of getting into a bit of a runaway state. So that's what those are. And pretty much any electrical device that uses a high torque or a high voltage, high current motor that needs sort of precise movement will have some sort of an electrical assembly or electrical design similar to this. So it's good to see that in there. So it seems like the next logical step here is going to be to remove this gold stem from the front, or the nose of the motor shaft here, and it's the same process actually as if you have ever installed one of these Z-ring mods to remove the rubber ring here and give a bit more rigidity, a bit less flex in the wheel. So what we need to do now is undo the little bolts, or the two Allen keys inside this collar here. That's going to allow us to slide the nose of the motor off. So far at least, this is all still stuff that I've done before, so I'm not delving into uncharted territory just yet. Okay, so that collar is now loose, and that should allow us to carefully slide this guy out. Now we do need to be careful here because obviously the pins for the connection to the wheel are inside as well, so we need to be careful we don't yank those. I don't really know. At some point I'm going to have to reach the point of no return and go, okay, I'm sacrificing this base, I don't need to be so careful anymore. But I'm not quite at that point just yet. I'm still in the mindset of hoping that this can be salvaged. So we've got two connections inside here. Now, interestingly, they are exactly the same connections as each other. So you do need to be careful that you don't muddle these up if you're reassembling later on. But thankfully, they are color-coded. You've got a black one and a, I think it's, again, I'm colorblind. It looks like orange and red, maybe. I don't know. No idea. Now we've got, I'll pull this collar off as well, actually. So now we should be able to slide the motor through, but I'm guessing there's going to be some sort of a fixture here as well into the motor housing, potentially. It doesn't seem to be moving freely at the moment. Also need to be careful I don't lose those two connections inside the stem. I might need to pull that out with some pointy nose pliers later on. All right, so we'll undo these 4 Allen key bolts as well. I keep on kind of defaulting back to trying to make this a guide because that's the type of video I normally do, but this isn't a guide, guys. This is just me pulling something apart and seeing what happens, basically. So again, don't use this as a disassembly guide. If you do need to repair your wheelbase, I do definitely recommend you send it to a professional. But I think it's interesting still to see how these things work, and you know, we have a broken wheelbase here, so we may as well make the most of it. All right, so it seems like same deal as before, even with those 4 bolts undone. It looks like we're going to have to kind of pry at this now. I can see if I look in the back here now, you guys aren't going to be able to see it on camera if I do, even if I do spin it around. So there's no point in trying to show you, but there is a bit of a gap there. I'm going to have to be careful I don't poke the screwdriver through the LCD. So I might, or LCD, the OLED display I should call it. So we might try to go from the corners here, I think. And again, just kind of get the screwdriver in there. Okay, there we go, that's off. Okay, it looks like the motor's actually coming out forwards. Yeah, I can feel the motor's actually loose now in the housing. So it looks like we are actually going to need to unplug everything off the back and then pull it through the front, which is a little disappointing. I was hoping we could kind of just slide everything out. Oh no, it will go backwards. Maybe. I don't know. I think what's happening now, yeah, okay. So what's happening is it is sliding out backwards, but the cable attached to the OLED display on the front is snagging because it's bolted on or screwed on to these little retaining clips here. So we need to remove those, I think. Probably disconnect it from the PCB here as well. All right, there's one. Don't like dropping screws inside things. Let's see if we can tip that out quickly. There we go. One. At least those weren't thread locked. I was worried they might be Loctited in place and really hard to get out, but wasn't the case. Okay, and we'll pop those 2 little clips off as well, so we don't lose them later on. Okay, that's given us a bit more cable to play with there. I'll actually just have another look and see if there is a way to unplug that on the front. Okay, yeah, now I can get a screwdriver in here and actually remove the entire LCD assembly. I don't know if you guys can see inside there though, there's a whole bunch of hot glue or some sort of a material there that's sort of designed to stop this cable from being able to be yanked out. But I think that if I do exactly what it's designed to not allow you to do, yeah, there we go, it's just kind of popped out. Hot glue is good like that because it holds it in place to a point, but it tends to sort of tear off in one piece if you need it to. So now, if I undo the 4 screws that are holding the OLED display in place, I should be able to pull everything else out. We might also need to somehow get this thread off as well, but we'll have a look at that in a moment. So let me undo these 4 screws. Okay, there's our OLED display now separated. Have to be really careful with that. Don't want to scratch that up. Okay, and again, it's got that horrible plastic stuff there to stop you from, actually looking at that, the way it's glued, it looks like the cables are actually glued into the male side of the connection, but the male side of the connection doesn't appear to be stuck to the female side. So I might actually be able to just unplug that. Let's just have a look here. Yep, you can unplug that pretty easily. And that might actually explain the reason why I know a lot of people are having problems with these after shipping. The display would be all garbled and kind of hard to read, and it would kind of be intermittent as well a lot of the time. I'd say that wasn't actually, and it may be just because I tugged on it when I was pulling it apart, but that could well explain some of the issues that people have been having with with their displays. Not, again, I would always recommend, you know, if you've just bought one of these and you're having problems, don't pull it apart yourself. Send it back for warranty repair or replacement, of course. But for those of you who are out of warranty, potentially that may be the cause of the relatively common issues with the OLED display not showing up properly. But let's set that little module aside now too. And we should now be able to slide that front housing off entirely. There we go. Now there is some sort of a black, almost tar-like thread lock stuff in there. But again, this is all cast metal of some description. Not sure exactly what kind of metal it is. It's quite light. Might be iron or something like that, I don't know. But you can see that material, that filter membrane in the front there as well. So all good. Set him aside too. So now we should be able to push the motor back through the housing. I don't know why I get so excited about this stuff. I love pulling things apart, even though I should be really upset that this is broken, but I am really enjoying this process. So there's our housing. And again, it is all metal. It's not plastic. And this is the DD1/DD2 motor. Now this is exactly the same physical motor between the DD1 and the DD2. For those of you who aren't aware, originally the DD1 was going to have a different motor, I believe, but they had some quality control issues with it or something. I'm not sure exactly what went wrong, but anyway, the long story short is that they ended up using the DD2 motor in the DD1 as well, but with different firmware, I believe. So we can actually see, interestingly, on the back here, it does say DD2 as part of the part number. Now, I don't know whether that's just one specific chip that kind of signifies whether it's one or the other, or whether there's more to it than that. I can't offer any insight on that, unfortunately. Now, I'm sure a lot of people will be wondering whether it is possible to flash a DD1 to a DD2. Theoretically, I guess it would be, but we'll pull it apart further and see exactly how things work internally. I'd imagine that the process for doing that would require some sort of proprietary software, or maybe even something like a JTAG or a KTAG to actually piggyback off the PROM or off the chip and flash it that way. So it's not something that I would expect we'd be able to do ourselves at home, but interesting nonetheless. So now I guess the next step is to disconnect these three connections here. We have to try and get all this plastic crap out, and then we can start to pull apart the motor assembly itself. So I've slowly just scraped away at this material here. I don't know exactly what it is. It's almost like dried up chewing gum that's been sitting in the sun for years and years, but we've chipped away at it enough now. It is softer than the plastic on the connectors themselves, so as long as you're careful, you can release it without doing any damage. So what we need to do now, I'm just going to get in there very carefully and try to wiggle that connection out. We might need to sort of pry it with a screwdriver, I think. There we go. Yeah, I was just worried that if we pull on the cables, there we are, those cables will literally just tear straight out of the connection before it releases. So there we go, that's one done. That was probably the easier of the two. This one down here is looking like it's got a whole heap of that nasty stuff on it. So I'll do the same thing again with this one. Took me probably a good 10 minutes to release that one. So just, again, need to take your time. And let's get this one unplugged. There we go. Okay, it doesn't look like we've damaged any of the pins. Is this still, no, that's not connected to anything. So I'll give you a nice close-up look at that actually. Just that dried up chewing gum type stuff holding those connectors in place. So we might try and have a closer look at the PCB in the back of this guy, because that's where I think, I'm not exactly sure where the split between the brains occurs, because obviously all the interface connections, USB and everything are all on this side, but there is quite a lot of brain activity going on inside the motor housing itself as well. So I'm guessing most of this is going to be down to power supply related stuff, maybe a little bit of USB and control interface stuff as well, but we'll pull that apart, have a closer look inside, figure out exactly how all that stuff works, and then we'll get to work on the motor housing. So to access the PCB in the bottom here, there's two little clips, it looks like, to remove this housing here. That should expose most of it, and then 4 Allen key bolts, 2 in either side, which should actually allow us to remove the assembly entirely. So we'll start off by popping that cover off. So push it in, it's one side. I'll try to do the other side without losing it. Okay, there we go. Slide this up. It's starting to get more important to keep track of what came from where now, I think. Pop it out of the housing so we can get a closer look here. So 4 bolts are removed. Should be able to just slide this guy on out. There we go. Okay, so that gives us a better look at everything that's going on here. And so I'm just going to snip the cable tie there. And that's going to allow us a little bit easier access in here to see exactly what's going on. So we'll take off this power connection as well from the other side. It does look like it's mostly power supply related stuff going on here, but there is a processor of some description sitting on the board there as well, which we'll get a closer look at in just a moment too. You can set those aside. We've got a 4-pin connection to our fan. So that would be a PWM fan, I would assume. So we've got, say, we've got power, PWM signal and RPM. And that would explain why the fan is able to spin up and spin down relative to the temperature inside. So I'm going to undo this guy, very gently tug on the wires this time because we can't really get anything else in there. And there we go, that's released. And now our rear housing, which is just the 2 brake resistors that we looked at earlier and the PWM controlled cooling fan. So we can set that guy aside now too. And we're left with our interface board here. So there's actually quite a lot more going on this board than I anticipated. If you sort of draw a line here, everything on this side, so on my right hand side, your left hand side is basically power supply for the motor, and then everything on this side is logic. It seems to be the division. Now we can see a couple of power transistors here. There's an induction coil there and a couple other bits and pieces. There's a cartridge fuse there too as well. So if you were to ever have a issue with no power supply at all to the base and the power light was on the power supply brick itself, then chances are that fuse is blown. We've also got our interface here for all of our bits and pieces coming in and out. So our peripherals, data connection, e-stop button, torque key, CAN bus, and all those things. And those are all controlled by the microcontroller chip here that we can see, which is a microchip DSP-IC33EP512MU810. And just having a quick look at the data sheet here, it's got quite a lot of stuff going on. A USB 2 OTG compliant full speed interface. So there's no point in connecting your DD2 to a USB 3 port, but you definitely do want to connect it to a USB 2 port if available. So that's an interesting little bit of information there. It has CAN bus built into it as well by the looks of things. And basically this chip is designed as a 16-bit data path here with 24-bit wide instructions, 16 by 16 integer multiply operations. We don't need to go all through this now. I don't think this is going to be interesting to most people, but this is responsible for the motor control PWM. So it controls the inputs actually going into the motor itself. Obviously it's controlling the speed of the fan as well. It's got 8.32 NS PWM resolution for those who are interested, 32-bit position counter and 32-bit index pulse counter as well. So 32-bit positional sensing for the encoder. And then the rest of the information probably isn't of great significance to any of you guys, so we don't really need to go through that, but I'll put a link to the data sheet down in the description for you guys to check out. So we've got a little voltage comparator here as well, a few of those going on. We've got a little quartz crystal chip here as well, probably being used for a clock chip. That's pretty common in electronics. They send a signal through a piece of quartz or a little quartz crystal, and that gives a regular pulse that can be used for timing events and things like that. Then really the only other things of interest here that are going on are we've got a USB input down here, our power button coming in. And I believe that that's a little thermistor chip. So that's going to be a temperature sensor or thermal probe. It may not be the only one. There's probably another one inside the motor as well, but we can have a look at that later on. And then this little chip here, that is an EEPROM chip or a non-volatile memory chip. So this is where our firmware for this particular board is going to be stored. So we do know when we go through the process of flashing firmware on a DD1 or DD2, there's a couple of different areas that get programmed. So I would imagine this isn't the only memory chip that we're going to see on the control board, but it is interesting to see that this board is not only responsible for the input and output for our external interfacing, the power for the motor as well as USB interface, but also seems to be doing quite a lot of the signal processing itself for the motor. So I think the next step now is to start pulling apart the motor assembly a little bit more. If you do have any more questions, specifics about this, let us know in the comments down below and I'll be sure to answer those to the best of my ability. But that is a closer look at the main board, as they're calling it. Now, interestingly as well, it does say on here DD2 main. So I'm assuming again that it will be the same board for a DD1, but that little EEPROM chip would be flashed with different firmware. Now again, I don't know whether that is programmable via USB or whether that's something that has to be K-tag or J-tag flashed, but it is what it is, so just so you guys are aware. But this is definitely labeled DD2, so there is a, whether it's physical or just software, there is a difference between the DD1 and the DD2 there. So we're up to what I think is going to be the most interesting part of this teardown now. We're going to be pulling the actual motor assembly apart and seeing exactly what's inside here. So there's a few things going on at the back here. You can see there's a little PCB here, which we can unscrew, which I'm not sure whether that's part of the encoder or the key inductive coupling charging or power system, or perhaps the optical data pass-through for the shaft here as well. It could be either one of those three, I'm just not sure until we pull it apart. But we did run into a little snag here trying to remove the back assembly. You can see all of those little screws that are in there are all stripped. We tried a couple of different screwdrivers to get these out. I even tried heating them up as well, just to see if that helped. But yeah, they're very, very, very soft metal. Now, obviously, you shouldn't be pulling this apart to this extent yourself anyway, but if for some reason you are trying to service one of these yourself, just be aware those are extremely soft metal. I honestly think that probably what it is they've put some sort of a liquid thread locker on there so that as soon as they're done up, they're never going to come out again unless you drill them out, basically. So that's exactly what we're going to do now. We've got our drill here with an easy out fitted to it. So the way this works is you drill a little pilot hole through the screw itself, and then you put the tip in and basically just drill it out. It should be that simple. So let's do that now. Got him. There's one. Oh wow, it actually broke the thread inside, so that's going to be really difficult to ever screw back on again. But hey, it worked. We'll get the rest of these screws out and get back into disassembly. So getting a little screwdriver in there. There's a little sticker there that we'll have to release as well. I don't see anything else that should stop this from coming off. It could be that we have to release this first, but if we feel too much resistance inside, we can always stop and come back. But that seems to be sliding off. There we go. Yeah. Go from this side as well. And this is, I think, where we're going to reveal the extent of the damage that we've done. Maybe there is a little lip inside there as well. It seems to be snagging up on this little bit of plastic here, so we might actually need to remove this too before we can get further out. So I'll slide the heatsink assembly off. That should allow this little piece of plastic to slide off too, and then we should be able to get this back cover off. So we'll just pop that back on there for now. Hopefully these ones don't strip as well. I just noticed there are more little baby screws in the front of the motor assembly as well, so we may end up having to tackle more screws yet, but get this heatsink off first. Good, didn't strip. Okay, slide her out from the heatsink. We got a problem there, okay, because the it needs to line up absolutely perfectly to slide through. That's okay. There we go, got him. Whew, that's sharp on the edges. Okay, there we go. So yeah, interesting design. It's just literally a heatsink assembly, and as we said before, it's got the active cooling that blows from sucks from the rear, I should say, pulls air through from the front, and those cooling fins just provide a little bit of extra cooling to the housing of the motor. So now we should be able to get this bit of plastic off too. How is that connected? Not sure. If we're not sure, we just start prying and see what happens. I'm not sure what's going on here. So I kind of expected that the whole thing would just kind of slide off, but it's not. I'm going to undo the screws, and hopefully these ones don't strip. No, these are good. So I'll take off this little PCB at the back here. So there's a couple of little plastic clips here that we're going to squeeze. And this is going to be a little bit tricky. I might even need a second set. Oh no, it just pops straight off. Okay, interesting. Just literally pulled out. So this appears to be a little optical blaster. You can see, or optical transmitter, I should say. There's a little I assume, I don't know if it's infrared or what it is, but there's a little LED there that transmits through the plastic lens. And that is shooting through the shaft. And then on the other side, that's going to be interpreted somehow as a digital signal. There must be a receiver on the other side, I guess, which receives the signal. So we'll pull that apart further and check it out later on, but it's a really clever little design, that. The PCB actually says DD on it as well, so I assume that this is something that's been designed for or designed by Fanatec as well. Pretty cool. Set that guy aside. I don't know whether it's going to make any difference to pulling this apart though. It doesn't look like it is. So yeah, may just have to start getting forceful in a moment, I think. So we've had a bit of a breakthrough here. I can actually see, you guys won't be able to see on camera, but there are some cables that are actually soldered to a PCB at the top of this, which is the reason why it won't come off any further. So I think we need to, it feels like this bit of plastic is actually going to pry off if I pull hard enough. There we go. Just like that. Yeah, just little plastic clips that were holding that on. But there is another PCB at the front too. It's a shame that there isn't a little bit more length on those so I can just kind of pry it out. Maybe I could just get past that edge. Maybe I can. I'm stretching my luck here a little bit. Oh, we got it. Okay, we're in. Okay, yeah, we'll definitely desolder these leads, I think, rather than chopping them. And then we can have a look in the back of this motor assembly. You can actually see there though, if I roll it on the side, that's the inductive coupling coil that handles the power. The optical sensor goes through, or the optical transmitter goes through the middle. And then on this side, I presume, I haven't had a look at yet, we can see the coil on the opposing side. And that entire assembly spins with the shaft. This is what we were talking about with an outrunner motor, where the entire outside assembly within the housing, of course, actually spins freely. And that's the reason why we need to have this coil system, so they're not actually making contact with each other, but because they're in close proximity, we're able to generate a voltage on the opposing side, just like in a transformer, really. It's not really advanced technology, it's just a different implementation of the same type of technology we see applied in a normal transformer. But we generate a voltage inside this side, and then that is how we're able to transmit power wirelessly. It has to be across a very small gap, of course, but exactly the same as the way you charge a mobile phone on a charging pad where you're not actually plugging anything in. So we'll get these desoldered now, and we can have a closer look at the PCB on this side, and then get into the motor some more. So safety goggles are on for this, just because if any solder were to flick up and hit me in the eyes, that would be a really bad time. So all we're going to do here is just heat up the solder. I'm hoping we can get enough heat into it here that it should just melt away. And originally I was going to try and suck it up with some braid, but I'm thinking there might be a little bit too much of it here to even bother with that. We'll see. See if it soaks it up. If I had a solder sucker, this would be so much easier, but I don't. So let's see. Almost there. Yeah, just be really careful it doesn't flick you in the eyes. Okay, that's one. I'll just clean that pad up as well. It didn't damage the PCB either, so we're good. Got him. All right, 2 down. All right, these last 2. 1 and 2. There we are. That wasn't so bad. So we've found at least some of the damage. This isn't necessarily all of the damage, but it's definitely a reason why this would not be functioning. And yeah, unfortunately it does look pretty terminal. There's some surface mount components on one of the PCBs here that are pretty heavily damaged. But I wanted to start off by sort of explaining exactly what's happened here, as well as a tip that I can tell you straight away. Now, if we look at the plastic around here, you can see some divots and some scrape marks. Now, thinking back, when I initially dropped this, I tried to turn it, and I actually did manage to crank it a couple of turns before it completely seized on me. It felt really stiff, but I kind of, you know, in my panic and my freaking out moment, I kind of, you know, tried to spin it. And that is probably what's done the bulk of the damage here, I would say, because this bit of plastic here, you can see where it's scraped up against the PCB here. And if we move over to this guy, you can see a very clear path of damage that coincides with the piece of plastic. So you can see a scrape on the sticker here. If we follow the arc around, you can see there's a missing surface mount component there. That's position C306. And again, you can see it's scraping around. And over here, there's a missing component again, C304. And then this little IC is actually broken off the board entirely. I just found that floating around inside the casing. So that looks to be, I can't read it, but it looks like it's probably some sort of a logic chip, something like that. Probably part of the encoder, which would explain why it was shaking and going crazy. If we follow it around again, we can see a big scrape mark across the surface of this guy too. And yeah, so look, one problem is going to be trying to actually source these components if we were to try and resolder these. I don't have the equipment to do this kind of micro soldering here in the studio anyway. I do have friends that actually have a friend who runs a lab who would be more than capable of doing this repair, but we would need to actually know what these components are, and I very much doubt Fanatec are going to just tell me the schematics of their board. So if we were to actually replace this PCB, it would probably work, but we just don't know what other damage has been done internally. So we're going to have to pull it apart further anyway to see whether there is any other damage. You're obviously remembering again that the shaft did push back a good probably 1/2 centimeter at least into the housing. So the bearing could be damaged, the coils could be bent, the magnets could be cracked, we just don't know. So there's no point in attempting to repair this without further diagnosing internally. So we'll pull this apart as well. There's a couple of chokes here. There was actually an additional data port here as well, or some sort of a connection port, which we weren't using. So I don't know whether that's for flashing firmware in the factory or something. We've got some capacitors sitting here as well, bit of a heatsink assembly. So there's obviously some heat dissipation that's necessary in here. And then we can get into the nitty gritty of the motor housing itself. So we'll pull the logic board off here and have a look internally at the magnets and coils and what actually makes this guy tick. So we'll pull this apart, have a bit more of a look at exactly how this works. So we'll start off by taking off the inductive coupler. So I'm guessing this is probably going to be soldered to the PCB, so it might actually be better to leave this on the PCB, but we'll just have a look in behind it first before we make that decision, because it may also be screwing. Given the length of those screws, it probably is actually screwing into the housing as well, so we probably will need to remove these to disassemble further. Okay, yeah, so that is just soldered directly to the board. So I think the easy thing to do here is going to be to just snip these guys off, because we can, if we snip it really close to the connector, we can resolder it again should we choose to do so. But as I said, this board's pretty well stuffed anyway, so I don't see us ever putting it back together. And that is 1/2 of our inductive coupler. Let's now remove the remainder of these screws, and we should be able to pull the PCB out of the housing. It looks like it's got a layer of maybe thermal interface material or something behind it as well. If you guys can see that there, but it looks like a giant thermal pad. So we may find that this PCB is actually physically stuck to the back of this housing, and that would make sense as well, because you can see we've got this kind of heatsink design here. So I'm guessing this does get quite warm. There's some motor driver circuitry that's happening in here as well. You can see just through this part of the board here, there's a little digital controller there for the power supply and everything. So yeah, not sure how well this is going to come off, but we'll give it a shot. We can pretty much assume that this board is sacrificial at this point anyway, so not too worried about what might happen. No screws through from the front holding anything in place. So now I'm just gonna, there we go. Yep, that came off pretty easily. Nice. That could have been a lot more difficult. Okay, so there's our thermal interface pad and the back of the, so yeah, it's just like a giant heatsink really. That's pretty much all there is to it. So yeah, it looks pretty much as I expected. This is the part of the board that is responsible for distributing the power through the power rails that we looked at earlier to the actual motor itself. So the control circuitry and the step down in voltage happens on the first PCB that we looked at earlier by the looks of things. Or maybe not the step down in voltage, I'm not sure. Haven't analysed it close enough to really know, but there were some voltage regulators and things on that board. So there's definitely something going on. It's not as simple as just the power coming from the main power supply going straight through to this board. So that did come off pretty cleanly, and we can see it's pretty much exactly the same as a thermal interface pad that you would have on on a graphics card or something like that. So let's have a closer look at this PCB now. So this, I think we can really break down into three main sections. We've got our power supply to the motor, which is the power that actually runs the turning of the motor itself. We've got the power supply that drives the power to the wheel, and then we've also got the positional sensor on the back here as well. So if we have a look at this side of the board first, and it is a two-sided board, which makes it a little bit more difficult to analyze. So we've got three clusters of transistors here, as well as some resistor packs. So it appears to be a three-phase power supply. I'm not 100% certain on that. My electrical engineering is a little bit rusty, so don't quote me on it, but that's what it appears to look like to me. So those individual chips are Toshiba N-channel silicon MOSFETs, or basically like an amplifier circuit. So they're TPH1R3 is the model designation on each of those. So we've got three clusters of those, and then some resistors underneath on two of those as well. So I think it's a three-phase power supply, but not 100% certain. That would also kind of tie in with what we saw with the three power rails going in as well, assuming that ground is coming from somewhere else. But again, I'm not 100% certain on this. We've got 5 capacitors here as well to filter the power. And then if we spin the board around, we've got a layered, what is it, a Z171B01, which I looked up is a high current choke. And then we've got 2 inductor coils here as well. So pretty standard kind of amplifier circuit. Now, interestingly, we do have 3 connectors as well as a little pin header there too. So our main connector here is our power connection for the DC power coming into the motor. Then we've got this connection here, which was connected to the main PCB as well via the ribbon cable that we saw earlier. And that's going to be our logic connection. That's going to be handling our communications and feedback loops, things like that. And we did have this additional connector here as well, which wasn't connected to anything. So I don't know whether that's for flashing firmware or something like that. When we also do have a little header pin here as well, which wasn't connected to anything. So not 100% certain of the function of that connection, but from what I can see here, it does look like it ties in to the positional sensor circuitry, which is this little section up here. So if we flip the board over now, we can see the, I guess, separation between the 3 circuits a little bit more clearly. So this section here, which is actually a sort of notched out area of the PCB entirely on its own, that is a 12-bit rotary position Hall encoder, or MHL200, and that's what's responsible for reporting the current position of the motor. So we'll talk about this in a little bit more detail once we've pulled the motor assembly apart a bit more. I want to understand a little bit more about how this works before I talk about it too much. Then over here, this section here appears to be the power supply to the wheel. So you'll remember our inductive coupler was connected via these 2 pads here. So we've got a couple of chokes here, an induction coil, a little rectifier circuit there as well by the looks of things. So that's our power supply to the wheel. And then this section over here appears to be all related to the motor driver circuitry, or the amplifier circuit that we saw on the reverse side. So you can see our 3 phases, what I believe are 3 phases there. So there's a couple of rectifiers here. You can see 2 of them. One of them there is the one that we saw that was torn off the board before. And those, all 3 of those are exactly the same. So they're S2181 rectifiers. And then we can see, again, some surface mount components there. We don't really need to go into a whole bunch of detail on that. It's just a basic sort of amplifier circuit. That little chip there is an M10Z7V, which I believe is a motor controller. I struggle a little bit to find information on that chip, but from what I can see, it appears to be some sort of a motor control IC. So I think that's about all the detail we need to go into on this PCB just for now. Next step now is to pull this guy apart further. We'll have a look at the reverse side where we connect to the, I guess, receiving side of the optical sensor for the data transmission, as well as the other side of the inductive coupler. There's a few more bits and pieces to look at there. So we'll remove that, and then we'll take the housing off and have a look inside the motor itself. So on the other side of the assembly here, we've got our other coil for our inductive coupling. So remember, this guy sits static and this guy spins around as the motor spins. Looks like we can pop this out pretty easily. Yep. So let's lift that up. It is soldered to the board, so I don't know whether we're really going to achieve much by removing it. I might actually pop that back on, but you can see there, that is our optical receiver as well. So remember, before we looked at this guy, this is the transmitter. So that sits basically right up against this tiny little gap there. And again, because this is able to spin around freely, we're able to get the signal through without any problems and without any contact. So it's a really clever design. I've got to say, I'm very impressed by the ingenuity that's gone into this, but I'm going to pop this back on for now because there's not really anything underneath it that we need to look at. And it's just going to keep it safe and make it a little bit more able to freely spin around. So let's pop this up. There we go. He's back in place. And yeah, let's undo these screws. See if we can remove this PCB entirely. There's going to be some sort of a connection behind it, surely. Although I guess because it does have the power there, maybe it is completely powered by the inductive coupler. I'm just not sure at this point. Remember, I'm learning as I go here. I haven't pulled one of these apart before, and I don't have access to a schematic or anything like that either. So I'm basically just kind of seeing what we find as we go here. So I'm going to remove this metal housing from the motor assembly now. We did already remove the screws that were in the front as well. We had to use the easy out to get rid of those as well. Unfortunately, they did strip. But again, like, this isn't something that you would ever be pulling apart yourself. So it's not really a criticism, but you know, if you were to attempt to repair one of these yourself for some crazy reason, you would likely run into that issue. So let's just set that aside. Again, it's just a metal housing, nothing fancy there. And again, you can see, this is actually quite interesting how, again, being an outrunner motor, that entire assembly is spinning with another PCB in the front there, and then the mechanism attached internally there with the bearing on the front. So really interesting design. I've never actually had a look inside a motor like this before. So we've removed the 4 bolts that were holding this plastic section in place, and it looks like it just comes away pretty easily here. So okay, all right, so interesting. So that's the connections to the wheel for power and data. So that's what ran through the motor assembly into the front. So when we remove all of this assembly, the actual motor itself is quite small. This is all there is to the motor. So interesting there, but again, a little bit more circuitry. We've got another little PCB on the back here, which is our, that looks to be our receiver. That's our optical receiver for the data connection. So we can remove that, and then that's going to feed the data itself through via the, I don't know which one's power and which one's data, but our 2 connections to the wheel. And that's what goes to the pin assembly in the hub that we looked at before. So this guy. So let's see if we can get this apart a little bit further now. Yeah, we're going to start off by undoing the 4 screws. This is really fascinating stuff. I'm loving doing this. Obviously, it still sucks that the DD2 got damaged, but at least we get to do something interesting with it. At least it's not just, you know, a case of throwing it out and never getting any value out of it whatsoever. So now there's going to be some sort of a connection between the 2 sides here, surely. So I'm going to be really careful with how I try to wiggle this out. Yeah, you can see the little clips here. So maybe the whole thing will come out. I'd rather the whole thing came out together. There we go. Cool. All right. So, okay, and there's a little connection there. So that's, again, that's quite clever. That's how the optical receiver connects to that other PCB, and that would have been the reason why we weren't able to remove that PCB probably before. So we've got our sender and our receiver, or our transmitter and our receiver, and obviously this one is able to spin around, and it's just purely a optical data connection there. So very, very clever. I wonder if we're able to actually do anything else with that. I wonder if it's just like a standard serial connection and we'd be able to actually use it to, we'll have to do some experimentation. It almost looks like what you'd find in an Arduino kit or something like that. It's not, it's a proprietary designed circuit, I believe. But yeah, we might be able to do something interesting with that later on. I'm certainly not going to throw any of this stuff out. Let's now see if we're able to remove this board. It still seems to be wedged in there pretty hard. What it is this, these plastic parts which are connected to this are actually a part of the same plastic assembly. So if I take this off again, then the PCB will lift out. So we'll go like this. Yeah, there we go. Okay. That wasn't so bad. Now these connectors probably aren't going to pass through the plastic, I would say. No, a little bit too thick. So we're going to need to unplug it from here. So, I mean, there's not really any need to unplug it, I don't think, because we can't really, you know, there's nothing to see here. It's just the connection on the back of the PCB, a few little test points or probe points on the back. So we'll flip down our induction coil there. And we can see this is the power circuitry that's purely designed to, I would assume, step down the voltage. When we use inductive coupling, we have to increase the voltage massively. I can't remember the magnitude of the voltage exactly, but yeah, it's really, really high voltage. So that's how we actually are able to transmit power wirelessly like that. And then we have to step that back down to whatever voltage the wheel uses, probably 5 or 12 volts. We've got another little coil there as well as a connector, which again isn't connected to anything. So not sure exactly what the function of that is. And then all the rest of this circuitry here all appears to be just dedicated to the data transmission. Obviously there was a connection through from the optical receiver that we looked at just before. So yeah, this board appears to just be power and data through to the wheel, which is kind of what we expected. But the really interesting thing here is that I'm not seeing any sort of a encoder or any sort of multi-position sensor. Remember we looked at before on the previous board, we had that little chip there that I said was a multi-position hall sensor. So there's a bit of a clue here. There's a little bit of a scrape there where when the motor got pushed through when it fell on the ground, it's actually crushed up against that chip. Now, I had a bit of a look here because I couldn't see any other form of sensor. And this little ring around the outside of the motor housing, remembering again that this is sitting right up against this like so, with just enough of a gap there that it's not touching, but it's nice and close. This ring actually passes right past that little chip. And you can actually see there's a little white mark there, which I assume is some sort of an alignment mark originally, and that's actually left some white paint on the behind on the little chip. Now this little strip here, if we have a closer look at it, is actually a magnetic strip. So, and this is an assumption, I don't know 100%. What I can assume though is that this little hall sensor here for our multi-position sensor is actually measuring the magnetic field around this strip, and that's actually how it's able to determine the position of the wheel, because there's no other sort of positional sensor that I can see at least inside. And if we have a look at the rest of the circuitry here on the motor, all we have now is just these 2 wires, which I'm not 100% sure what they are yet, and then the 3 power rails which go through for our, I assume, our 3-phase power input. So that is, and again, this is an assumption, I could be completely wrong here, but it looks to me that, yeah, that little chip that we saw here before is a Hall effect sensor, and it's using this little magnetic strip around the outside here to determine the position. So again, very, very cool. So that is pretty much everything in terms of the data transmission, the power transmission, the inductive coupling, the optical transmission. Everything else that's left behind now is purely just down to the outrunner motor itself. So let's go ahead and pull this apart a little bit further now and see if we can get a good look inside at exactly how this part of it works. So we've removed the 6 little screws out of the back of the motor housing here. They were quite tricky to get out, but we didn't have to use an easy out this time. I was able to get them out with an Allen key. Now, it's not coming off at the moment, but we also do have this little retainer in the front here. So I managed to dig up this tool out of my garage, which I don't think has been used. I remember my dad having this when I was very, very young. So I think this has probably been unused for about 30 years, but we're gonna put it to use now. A little seal here as well. It's gotten a little bit bent in the process, but that's okay. All right, we can see the metal ball bearing assembly there as well. Now this is kind of seized up now because I've released other things around the outside, so it's all kind of a little bit twisted up, but we should theoretically be able to slip this whole assembly out through the back now. See if we can make that happen. So after about an hour of trying to figure out how to get this housing off, I think we've come up with a solution that should work. So the magnetic force holding this housing in place is so strong you can't just sort of pop it off with your bare hands. We tried all sorts of different ways of levering it off, and I'm just going to be really careful how I pick this up too. I don't want to pinch my fingers, but basically we've bolted a plate to the back here, and we've put one of the original studs from the outer housing in there with a little nut underneath it, so we can kind of wind this through, hold the nut in place with a pair of pliers, and as we screw this down, it lifts the whole assembly off the back of the thing. Now it's making a mess of the back of the motor, unfortunately, but it is working, and the aim here is to basically get this apart as far as we possibly can to show you how everything works. So hold it in there, and hopefully we'll get to a point where the magnetic force won't be so strong and it'll just kind of come flying off. Hopefully it doesn't hit me in the head or go through the roof or something. I have no idea what's going to happen here. Ta-da! we can't really see a whole lot more having done that either. No, I think that gives us everything we need to be able to see for the purpose of the remainder. Okay, so this is about as far as I think we can go with the disassembly before we have to start breaking things apart. And I don't think it's really going to tell us a whole lot more if we do that. So let me give you a quick rundown on how an outrunner motor works. Now, I'm not an electric motor expert by any means, so if you know a lot more than I do, please feel free to fill in the blanks in the comments down below. But basically what we have here is a magnet assembly which sits on the outside, and this is normally bolted, as you can see with the holes there, to the back of the shaft here. So this is what rotates when the motor spins, obviously, and then this is rotating around the back here. This is bolted on, so the whole thing rotates together. So that's why it's called an outrunner motor, because the outer housing or the shell of the motor actually rotates around the windings rather than the other way around, which you would find in a conventional motor. So if you want to understand more about the different types of motors used in direct drive wheelbases and their pros and cons, specifically for sim racing, then we do have another video linked down in the description. I'll put it above my head for you as well, where that is explained in greater detail. So we're not going to go into a huge amount of detail now about all that stuff, but basically the way this works is we've got 3 different power rails coming in, as we said before, and those correspond with different windings on the stator here. So as we can see here, these little strips of metal here are actually coil windings that are going around. So as we energize each one of these 3 rails through here, this creates an electromagnetic field, and we can alternate the way that current is flowing through to create the rotational force. And because we can pulse that electrical current in very specific ways through those 3 power rails, we're able to create very precise movement. And then through the feedback loop, we can calculate how we want to move and respond to what's going on inside the game, and also counteract the forces that you're actually putting through the rotor. So the electromagnetic force is created between the energized windings in the stator here and the magnets inside the outer core here, the whole thing rotating together. So I think that pretty much explains everything we need to know about how the motor itself works. I'll put some links down in the description for you guys as well, where you can learn a little bit more externally. But yeah, I think that is pretty much the teardown complete. So there you go, guys. That is a complete teardown of a Fanatec DD wheelbase. So if you do know a lot more than I do about this stuff, then feel free to chime in the comments down below. As I said, I'm not the world's expert on these things, but I had the opportunity to pull this apart after an unfortunate sequence of events. So I figured I may as well do it and you know, share as much knowledge as I possibly could throughout the process. But if you did spot any mistakes that I've made or anything that I've explained incorrectly, please do let us know in the comments. It's always a community effort with these things, but hopefully what I've shared today has at least taught you something, and yeah, hopefully you found it interesting. So let's just quickly recap and run through what we have here. We've got the little stem that connects to the quick release. That is connected through some wiring to the data and power connection that we had on the back of the motor assembly here. We had the wireless key charging or inductive coupling system that is responsible for powering the wheel wirelessly, which is really cool. We've got the little optical transmitter and receiver here as well for actually passing the data through to the wheel without having to have any wires either. So when Fanatec talk about their wireless power and connectivity solution, obviously there are still connectors inside the wheel itself. We all know that by now. There's pins on the back of the wheel, but they're able to, through their inductive coupling and optical systems, allow a pass through of data and power through the motor itself, which is pretty clever without the need for any sort of proprietary protocol like Bluetooth or anything like that, which obviously does lower latencies and things like that too. Now, I've never had any problem with latency on any of the wireless wheels that I've tested, so I've never really found that to be an issue or a real particular advantage with the Fanatec ecosystem, but it is cool to see them sort of thinking outside the box and taking their own approach with that. And just overall throughout this process, I've been quite impressed with just the level of engineering that goes into this. I think a lot of people think that it's as simple as just connecting a big electric motor to, you know, some sort of a control box, and that's pretty much it with just some software on top of it. But as you can see, a lot of stuff goes into making this work. So moving on from that, we had our input and output control interface here, and I was a little bit surprised at just how much of the processing actually takes part in this part of the electronics. I thought a lot of that might be actually taking place inside the motor itself, but it seems like most of the smarts are actually taking place on the I/O board here, which is responsible for controlling the motor as well as handling the inputs and outputs for the various peripherals, and most of the driver circuitry here, where we're converting the power input to the DC signal that goes into the motor takes place on that board as well. And the power obviously goes into the motor via this little connection here. We've also got the little ribbon cable here, which connected to our optical transmitter, and then another ribbon cable which connected to our motor assembly for the more precise control side of things. So then on the back of the motor, we had this PCB, which was hidden behind a big metal plate, which also acts as a heatsink. And this was responsible for what I believe is the power to the wheel itself. So this little circuit here was what was feeding the power through the inductive coupling system to the wheel. We also had the positional sensor here as well, and that was actually quite a clever design. I'm not 100% clear on exactly how the sensor works, whether that little chip there is the sensor itself or just some sort of a processor, but it appears to interpret the magnetic field from the magnetic strip around the outside of this rotor here. And that was really quite impressive. I was quite surprised at how that worked. So assuming that I'm correct on how that works, pretty impressive stuff. And then we had the power amplifier circuit here for driving the, what I believe to be 3 phases to power the motor there as well through those transistors. We had some capacitors, some induction coils and chokes and things like that. And yeah, that was all pretty straightforward. And then we moved on to the outrunner motor itself, which was very difficult to pull apart, but we got there in the end. And yeah, as we said, we've got the wound coils on the housing itself, and then the rotor and the outer housing with the magnets rotates around the entire assembly. So there you have it, guys. Again, if you do have any questions or want to know anything more, there's some links down in the description to further reading on how outrunner motors work fundamentally. And of course, if you do have any specific questions about this process, feel free to hit me up in the comments below. Now, as I said a few times throughout the video, I definitely don't recommend trying to repair one of these yourself. So there are service centers in most countries, I believe, that can do this sort of thing for you. And you know, we did have to get pretty heavy-handed with a few parts to get this apart. So definitely not something I would say you should be doing yourself unless you have prior electrical experience. But hopefully you've learned a thing or two from this video. Hopefully the unfortunate event of breaking the DD2 by dropping it about 1.5 meters onto the ground is at least going to be beneficial to you guys, in that you get to see how these things work internally. So it's not all for loss. But thank you very much for watching as always, guys. Hopefully you've enjoyed it, and I will see you guys again soon. Bye.